Okay, so today we're going to look at finding trig ratios for different angle measures, right? Different angle. We talked yesterday about how angles are positive if they go counterclockwise and negative if they go clockwise and all that different stuff. And, some other words we talked about were coterminal, right? If two angles in standard position have the same terminal side, they're coterminal. So like a simple example of that would be 30 degrees is the same as 390 degrees. Coterminal angles always differ by 360 degrees or a multiple of 360 degrees. So what I like to do is if my initial angle that I'm trying to solve for is not between 0 and 360, I either add 360s or subtract 360s until it gets there. Because then I just have to know one rotation really well, and I can always kind of refer back to that. A lot of times if I have a negative angle, I'll add 360 and hopefully it'll become between 0 and 360 positive to make that easier. So that coterminal idea really extends us to all these different angles. But I think the most beneficial thing you can do at this point though is we can know the 15 values we're going to put in this table. Okay, this is this is like on the x-axis, this is on the positive y-axis. These are the three values that we need to know, have memorized within the first quadrant. So I like to think of it as a table. I would recommend maybe making 15 flashcards for these facts. If you know these really well, everything else will really become much easier. So thinking back to our unit circle, which we filled out, the sine of 0 is 0. The sine of 30 degrees is 1/2. Sine of 45 degrees is radical 2 over 2. Radical 3 over 2, and 1. Notice it counts up. We talked yesterday about some patterns you could look at. It's radical 0 over 2, radical 1 over 2, radical 2 over 2, radical 3 over 2, radical 4 over 2. Then you simplify and I get that. Once you know those, now you know the cosines. It's just the opposite order, right? You start at 1, right? Because when you're on the x-axis, the x value is 1. That's the cosine value. And then we have radical 3 over 2, radical 2 over 2, 1/2, and 0. Right? So the same 5 numbers. So it's not 10 independent facts, right? It's just the same 5 facts, just kind of arranged differently. And then once you have these, we can find the tangent. I don't want to think about x's and y's. I'm just thinking about it's the sine divided by the cosine. Okay, so 0 divided by 1, 0. 1/2 divided by radical 3 over 2, we can work that out. It becomes radical 3 over 3 when it's rationalized. We should be able to work that out. For 45 degrees, it's radical 2 over 2 divided by radical 2 over 2. It's the same number twice, so it's just going to be 1. Radical 3 over 2 divided by 1/2 is radical 3, and then 1 divided by 0 is undefined. Something I didn't do a great job at. You really will avoid a lot of problems if you make your radical and then a horizontal fraction bar. Radical, horizontal fraction bar, and make it obvious that only the numerator is under the radical. Sometimes if you get sloppy and write like the square root and you have 3 halves underneath it, that's a different number than radical 3 divided by 2. Okay, so these are our building blocks. This is what we have to start with. We have to know these values. So make sure you have those written down. It should all line up with what's on your unit circle we've already talked about. Right? You could find all of these central ones here, 30, 45, and 60 by knowing your 30, 60, 90 right triangle and your 45, 45, 90 triangle, right, with the hypotenuse length of 1, or any ratios that would fit in there. It'll give you these same values. So that's the first part, okay? So we're going to refer back to this shortly. But the next thing that we need to do, and this is on the back of yesterday's worksheet, where it talks about on the coordinate plane below, list any of the trig functions that would be positive in value in each quadrant. And actually, I might not recommend listing all of them. Let's focus on the big 3. Okay, I don't know what to call it, but the 3 that we talk about, right? The 3 we just looked at a big table for. Because we know that, for instance, if we have the sine value, we know the cosecant is its reciprocal, correct? And we know that if you have a number and it's reciprocal, they will either both be positive or they will both be negative, right? Taking the reciprocal does not change the positive or negative value of the number. So that means whatever it says for sine is also going to apply to cosecant. Whatever it says for cosine is going to apply to secant, tangent to cotangent. So let's look at, we have our, I just have a coordinate plane. I put a circle there, not really sure we needed it. But I want to think about in the first quadrant, right? In the first quadrant, we know x and y are both positive, right? So, would sine be positive? Sure, it's the y value. Cosine? Tangent? Yeah. So in the first quadrant, we say that they're all positive. Right, that's why, and think about the angles of the first quadrant, it's between 0 and 90, just like with an acute or a right triangle, and you have the acute angle, you're finding the trig ratios, it's always positive. Nice place to work in there. But let's look at the second quadrant. Now remember we number them 1, 2, 3, 4 because that's the way the terminal side would open, right? Counterclockwise. So over here in the second quadrant, we know that x is negative, but y is still positive. So sine, still positive. Cosine, negative. Tangent, well, it's a positive divided by a negative, so that'd be negative also. Okay, so over here in the second quadrant, we get that the sine is positive. Yeah, I'm not sure the unit circle is helping me here, so let me get rid of it. So here we get that the sine is positive. And again, as we mentioned before, that also means the cosecant is positive. But the other four trig functions are all going to be negative, correct? All right, so then if we look in the third quadrant, well, here x and y are both negative, right? So sine would be negative, cosine would be negative. What about tangent? Positive, right? So you said a negative divided by a negative. So the tangent is positive along with the cotangent. Right? It's reciprocal. And then to kind of finish this thing up, we're down here in the fourth quadrant where x is positive, but y is negative. So sine would be negative, cosine's positive, tangent would be negative. So down here we have the cosine is positive, and that would also be the secant as well. Good? We okay there? All right. So if you'll notice, each trig function is positive 2 places and negative 2 places. If you take sine, it's positive in the first and second. It's negative in the third and fourth. If you take tangent, it's positive in the first and third. It's negative in the second and fourth. Cosine's positive in the first and fourth, negative in the second and third. So they're 50-50, right? So now, what this is going to allow us to do is if we know where the terminal side of the angle in standard position is at, we will know if we're finding a sine, whether it's going to be positive or negative, or a tangent, whether it's going to be positive or negative. Okay? So the last piece of the puzzle to combine our table of values from the first quadrant along with this picture, which the way that this is, that I learned to remember this is the little saying, all students take calculus. Just so it's in the right order. It's just ASTC. All, sine, tangent, cosine. Just so you can remember that. If you want to make up your own saying, have a blast. But all students take calculus is the one I learned. It's like, please excuse my dear Aunt Sally back in grade school in order of operations. Okay, so we good there? Okay, the last thing that we need is we need to know about the reference angle, which we talked about yesterday. Just to review, the reference angle is the smallest angle formed by the terminal side of theta and the x-axis. Okay. And usually we use the symbol, if we're calling the original angle theta, we usually call the reference angle theta bar. Just theta with a line over it. And for this, we always keep it positive. So kind of, I know that we talked yesterday about direction and counterclockwise and clockwise, but for reference angles, you just want the angle. You don't really care if it's positive or negative. You just want the angle. So how can we put all this together here? Let's go ahead and take a look. So I'm going to go ahead and, I guess I ran out of board, didn't I? So we don't really, here, what we can do. We could get rid of this. We got the reference angle. We know what it is. We're not really going to use it. We just get the idea. So for instance, if I'm asked to find, let's say the sine of 210 degrees. Okay, let me just kind of give you my thought process, a nice way that I would recommend that you try it, and we're going to take some time with your table mates here to try it in just a few minutes. I just want to look at maybe a couple of them here. So the first thing I'm going to do is I have to figure out in which quadrant does 210 lie. If you don't know, you're going to have troubles with this. But we know that this is 0, 90, 180, 270, so it must be in the third quadrant. So I'm going to go ahead. There's the initial side, there's the terminal side. That's a 210 degree angle. The next thing I want to figure out is what is theta bar? What is the reference angle? Okay, that's the, unless it's on the y-axis, it's the acute angle. But I guess if it's down here, it's not really acute, but it's the smallest angle. So that would be this angle right here would be theta bar, right? So this angle is theta bar, and that's 30 degrees, okay? Once I know that, I know the number my answer is going to be. The only question left is it going to be positive or negative? Because I know from my table of values that I've memorized that the sine of 30 degrees is, right, it's 1/2, right? So from this, I know the sine of 30 degrees is 1/2, right? So the answer is either going to be 1/2 or negative 1/2. I got a 50-50 shot at this point. But we remember all students take calculus. So in the third quadrant, tangent is positive. Sine's not. So that means our answer is negative 1/2. Now, you do a couple dozen of those, you get a lot quicker, right? You start to know these facts better. But this is the type of question you're going to see tomorrow on our little trig value quiz, right? We're going to try to keep it pretty reasonable, but we can get a lot more involved problems. Maybe let's look at one more, and then I'll have you practice. Let's look at one of the not big three trig functions. Yeah, let's maybe look at some weird angle that seems a little bit strange. Okay, so let's try, we want to evaluate, how about the cotangent of negative 225 degrees? Oh, let's do it more interesting. How about negative 240 degrees? Okay. So the cotangent of negative 240 degrees. First thing I realize, I really don't like negative angles. So I'm going to find a coterminal angle. Okay, so because they're coterminal, right, they have the same terminal side in standard position, they're going to have all the same trig ratios. So that means instead of actually looking for this, I can add 360 to this, and this is going to be equal to the cotangent of 120 degrees. Does that make sense to everybody? That it would be, now, does that mean that negative 240 is the same as 120? It doesn't. It just means they have the same terminal side, therefore the same trig ratios. Okay, so we're still answering this question, but we're going to think about this one to help us. Now, do we know where 120 is at? Which quadrant? It's in the third quadrant, right? Or second quadrant, right? Now, I don't really know my cotangents very well, but I know my tangents well, right? So, if this is 120, what is our theta bar going to be? What's this angle right here? would be 60, wouldn't it? So if theta bar is 60, well, I know the tangent of 60 degrees is radical 3, right? Now, would tangent in the second quadrant be positive or negative?
Negative.
Would be negative. So the tangent of 60 is radical 3. The tangent of 120 is negative radical 3. Right? Now, if I want to actually know the cotangent of 120, I just have to take this reciprocal, correct? So for the cotangent of negative 240 degrees is going to be 1 over negative radical 3. We're going to rationalize that by multiplying a radical 3 on top and bottom, and we get negative radical 3 over 3. What do you think? Now, say you want to check this on your calculator, which is not a bad way to check it. Like this would have been easier, right? You make sure you're in degree mode, and you type in sine of 210, you get the answer. If you look at your calculator and you try to type in cotangent, there's not a cotangent button. I've never seen a cotangent button on a calculator. There is a tangent inverse, different function. That's not the reciprocal. So if you wanted to check this on your calculator, you'd have to type in 1 divided by the tangent of negative 240 when you're in degree mode. And then that decimal it gives you should be negative radical 3 over 3 if you compared that decimal. Okay, so there's a lot going on there. So let me get you a paper. Let's try some of these and see how it goes. Okay, so if we have this problem here, the cosine of t is equal to radical 2 over 3 in quadrant 4. I'd make my v a little bit more v-ish, I guess. Okay, find the remaining trig ratios. So we're going to find the other ones. Now, we did a very similar problem to this last couple days, but it talked about an acute angle in a right triangle. We can use all the same techniques. All we have to do is make sure that the signs, the positive or negative values of our ratios, match what should happen in quadrant 4. Okay, so right away, as soon as we see this, quadrant 4, we know that all students take calculus, correct? So I know that when I do this, I'm going to have a positive cosine and a positive secant. Everything else is going to be negative. So I could even, a couple things you could do. Sine of t, cosecant t. We said the cosine of t is radical 2 over 3. The secant of t would be 3 over radical 2. But we just do the multiply by radical 2 over radical 2. So 3 radical 2 over 2. And then we know we want to find the tangent of t and the cotangent of t. You can even, at this point, I know that these are all going to be negative. I would also check it back at the end because sometimes it's easy to miss those things. But let's take the fact that we know here that the cosine of t is radical 2 over 3. So we know the ratio. So I can draw any generic right triangle. I'm going to call this angle t. The adjacent would be radical 2. The hypotenuse would be 3. We used the Pythagorean theorem to find the opposite side. Right? Nothing too new here, I hope, right? So let's see, you get 2 plus something equals 9. So that would be radical 7. We okay with that? Fits the Pythagorean theorem. So let's see, our sign then would be radical 7 over 3. We know it's negative because it's in quadrant 4. So here's our sine of t. For our cosecant of t, well, we know we want to take the reciprocal. So that's negative 3 over radical 7, which is negative 3 radical 7 over 7. Again, we're always rationalizing, right? It's like our thing. Again, sine and cosecant are negative. For tangent, I get radical 7 over radical 2. Again, negative. So that's negative radical 14 over 2. So multiply the top and the bottom by radical 2 to rationalize that. And then we get radical 2 over radical 7, and that's radical 14 over 7 for the cotangent. And just to check, we have 1, 2, 3, 4 of them are negative, and the 2 that are positive are going to be cosine and secant. Does that work for us? The other type of problem that maybe we should look at here, kind of wrap it up, is sometimes, suppose theta has its terminal side in quadrant 3. Okay. Determine the sine, S-I-G-N, of, we just get to make stuff up, the sine of theta times the cosine of theta divided by the tangent of theta times the sine of theta. It's just some expression, right? But if we're in quadrant 3, we know the positive and negative values, correct? In quadrant 3, remember again, all students take calculus. So everything's negative except tangent and its reciprocal, which is cotangent. So what I would do here is I would say, well, that's a negative times a negative over a positive times a negative, just like a sine table we would make. So we get a positive on top, a negative on bottom. Positive divided by negative would be negative. Yeah, question?
Could you cancel out the 2 signs and then just...
Yeah, you totally could have. Yeah. I was going to be cute and put secant or something, but yes, you could. Yeah, you could simplify it, and we'll do a ton of that later on. Yeah. So that's what we have.